Hey, good evening. Instead of doing something ridiculous tonight, I figured I'd just start with a joke. What has one horn and gives milk? A milk truck. Okay, today we're going to start talking about factors that affect climate. It's going to be two parts. Today we're just going to talk about water. Next time we'll talk about all the other things that affect climate. For today, just water. Water is that important. Jumped ahead of myself. When we're talking about water, I don't mean just the liquid water, like what's in the lakes and the streams and the oceans. I also mean water in the air in the form of water vapor. Both water vapor and liquid water act to moderate the temperature. Now, what I mean by moderate is make it more in the middle. So in the winter time, if I'm moderating the temperature, it's actually making it a little warmer than it would be someplace else. In the summertime, moderate means make it a little cooler. So if you have an area with a more moderate climate, say like San Francisco, California, or Seattle, Washington, places that are near an ocean or a large body of water, their climate is more moderate and they have less total range of temperature. So their wintertime temperatures are a little warmer, their summertime temperatures are a little cooler. The total temperature range for some place like Seattle between their winter lows and their summer highs might be maybe, wintertime, maybe it's usually in the around 40, 45, something like that. And then in the summer, maybe it gets up to like 70. So you're talking about maybe a 35-degree temperature range. Now compare that to a place that's more continental, some place that's located mid-continent, like Fargo, North Dakota. In the summertime, Fargo can be 100 degrees. In the wintertime, Fargo can be 30 below zero. So you're talking about a temperature range of 130 degrees. Same latitude as Seattle. The difference is the water. Seattle is located near an ocean, Fargo in the middle of a continent. Okay, a couple more things we have to talk about with water. The first is evaporation. When liquid water evaporates, that's a cooling process. Let me give you an example. In the summertime, you're at soccer practice, whatever, it doesn't matter. And you're sweating. Well, what is sweat? Sweat is water that's given off through little pores in your skin. And the purpose of it is to evaporate, which cools you. If you're ever out on a really, really humid summer day, the water doesn't evaporate as quickly because the air is already filled with water. And that's why it's humid. You don't evaporate the water off your skin quickly, and you don't cool efficiently. On a very dry summer day, no matter the temperature, it's going to be more tolerable than a humid summer day. Case in point, you go to Las Vegas, it's 115 degrees outside, you go, it wasn't that bad, it was a dry heat. Humid is worse than dry, thermally for people, because the water evaporating off your skin is a cooling, or acts to cool you, I guess would be a better way to say that. So, evaporation is going to occur at a higher rate when the temperature outside is hot. The air molecules are moving faster, which allows the water to escape, like an individual atom of water, to escape from the lake or the pond. If it's moving faster, it's easier for it to escape and get away off into the air. The next factor is if it's dry. Obviously, think of the air as a sponge that can only hold so much water vapor. When it's completely dry or empty, there's more room for the water to evaporate into the air than there is if it's saturated or very humid outside. And then the last one is wind. When it's windy out, water can evaporate more quickly because the air mixes. Now, when the initial evaporation occurs, it's occurring, I jumped ahead of myself, PowerPoint, naughty. The evaporation is occurring in a very thin layer just above the water, maybe only a few millimeters thick. If that layer isn't disturbed, then that's the only layer that gets saturated with water. If there's a little bit of wind, that layer mixes a little bit, and then more water can evaporate into the air. If it's very windy out, the water vapor might mix into the bottom kilometer of the atmosphere, allowing for a lot more water to evaporate. So we have three factors that affect evaporation: the temperature, the humidity of the air, and how windy it is. Okay, transpiration. You create energy through a process called respiration. You take in oxygen, Chemical reactions occur in your body with the oxygen, the food that you've eaten, and you create energy. Plants do it slightly different, as you know. They do photosynthesis. Now, that whole process that plants do is called transpiration. It's when they take in carbon dioxide, they take in sunlight, they give off water vapor, and they give off oxygen. And that chemical reaction creates energy. That's all the stuff I just said. Now, there's a term we call evapotranspiration. This is a huge vocabulary word. Not important, it's just really long. It is important too. Evapotranspiration is the word we use to incorporate all of the evaporation and all of the transpiration occurring in a particular area. An area that's going to have more evapotranspiration is going to have all of the things that we said about evaporation. It's going to be warmer. It's going to be drier air and windy. But an area that's going to have more transpiration is going to be an area with a lot of plants. So while evaporation occurs more quickly in a desert, there aren't a lot of plants. So evapotranspiration is not exactly the same, but it's close. In fact, an area like where we live has a lot of evapotranspiration in the summer. It's warm, not particularly windy. The air is kind of dry, but we do have a lot of plant life here, and you wouldn't believe the amount of water that a plant can put into the air. Third factor of water we're going to talk about is condensation. When water vapor turns into liquid water. This is the opposite process, head crab down. This is the opposite process of evaporation. If evaporation is a cooling process, then condensation has to be a warming process. So whenever water, or water vapor, in the air starts to condense into cloud droplets, there's warming occurring in the atmosphere. Warms the atmosphere. Finally, precipitation. Obviously, precipitation has a huge effect on climate just because we name, and we haven't gotten into how we name climate areas and how we classify them, but we classify them by temperature and precipitation and plant life. And so it's a third of this classification is precipitation. Precipitation occurs when you have condensation as those little tiny cloud droplets, which are very, very small. If you've ever been in fog, you're in a cloud. Fog is a cloud at the surface. And maybe you've noticed, maybe you haven't noticed, there are individual little tiny droplets of liquid water when you have fog. Those little tiny droplets higher up in the sky will collide. And when two water droplets collide, bloop, they stick together. And then another one, bloop, and they stick together. And they get bigger and bigger and bigger. As they get bigger and bigger and bigger, they get heavier and heavier and heavier. And eventually, the uplift in the atmosphere that is causing the condensation to begin with, there's basically wind moving up. Once the weight of that droplet is so much that the wind moving up can no longer hold it up, it begins to fall. Sometimes it falls and it re-evaporates as it falls. That's called virga. Other times it'll fall all the way to the ground. Clouds. I thought precipitation was the last one. We got to talk about clouds too. Sorry. Clouds. In the daytime, a cloud is going to block sunshine. You've probably noticed this. Cloudy days tend to be cooler than sunny days. It's blocking the sun from reaching the surface and reflecting the sunlight back out into space. If you've ever flown on an airplane and taken off on a cloudy day, it's unreal. Especially if it's a really murky, dark day. You're down on the ground, you take off, it's dark, maybe it's raining, you fly up and you fly through the clouds, and as soon as you pop out through the clouds, the sun is blindingly bright. Very, very bright. So bright that you usually have to close the window shade on the plane because you just can't see. That's why pilots always wear awesome aviator glasses. That's because not only do you have the incoming sunlight, but you have 85% of that sunlight reflecting off the cloud back out into space. So it's almost like you've got almost double the amount of sunlight just above the clouds. In the nighttime, clouds act a little different. They're actually absorbing the infrared radiation being given off by the ground. So all during the daytime, the ground is absorbing visible light and re-radiating infrared. When nighttime comes, It stops absorbing visible because the sun is set, but it's still re-radiating infrared. So that infrared re-radiates all night long. The coolest temperatures of the day are going to be at sunrise because the ground is radiating heat all night long. If you have clouds, however, that infrared travels up towards space, hits a cloud, bam. Cloud absorbs it and then re-radiates it again. But if you think about it, it's re-radiating in all directions. So 50% of that re-radiated radiation is still going to continue on out into space. But the other 50% that was heading out into space gets radiated downward and warms the atmosphere. So clouds during the day act to cool. Clouds during the nighttime act to warm the Earth. I'm all done. Once again, if you have any questions or had any questions, you can look them up on Google or write them down on your paper, and we'll talk about it in class next time. Thanks a lot.